Welcome to the Inspiring Tech Leaders podcast with me, Dave Roberts. A couple of months ago, it was suggested that I create a podcast that covers the topic of infrastructure as code. Well, with one thing and another, it's been incredibly busy. But now, with the holiday period, I've got some time again to put together another podcast, and infrastructure as code seemed like a great subject to discuss. So let's kick off by defining what is infrastructure as code, or IaC as it's also known. Infrastructure as code is basically the management and provisioning of infrastructure through code instead of using traditional manual processes. So my own career path was developed in this area of IT infrastructure. So I know all too well what it's like to build scores of servers with identical builds. And the great thing about infrastructure as code is that you can create a configuration file with all that infrastructure specification included, which can then be reused in a consistent manner over and over again. So this obviously helps to save time, effort, and thereby also helps to reduce costs by being more efficient and creates a reliable way to deploy new infrastructure. It's also not just the provisioning that IaC can help with. It's also an efficient way to decommission infrastructure when it's no longer required. Infrastructure as code encourages better behavior and governance while also avoiding any undocumented ad hoc changes in the configuration or any manual changes that can introduce errors which could potentially cause a whole system outage. So codifying your infrastructure provides an opportunity to create modular components that can then be joined together using automation tools. However, it's important that you treat infrastructure as code in the same way as you would with any software application coding. Ensure there is good version control in place and the management of your source code. Infrastructure as code, if managed correctly with version control, can help to avoid situations known as configuration drift. This occurs when manual changes or updates are applied over a period of time. It is important that all changes are documented and tracked to avoid any versioning issues. Versioning will help enable you to roll back to an appropriate point in time and provide reassurance that your builds will operate as expected. There are plenty of options to help you manage infrastructure as code, automation, and configuration. Some of those tools include things like Terraform, Chef, Puppet, SaltStack, Pulumi, CloudFormation, and Ansible, just to name a few there. There are many blogs and videos that discuss the pros and cons of each configuration management tool as well. Some of these tools you can quickly rule out. For example, if you're working in an Azure environment, then AWS CloudFormation is not an option, as it's specific infrastructure as code to manage AWS infrastructure. Whereas if you're using a platform agnostic tool like Terraform, then that will allow you to manage platforms across multiple providers like Azure, AWS, Google, Oracle, Heroku, and many more. Some of the tools are open source, and some support different types of programming languages. So overall, you need to find a tool that aligns appropriately with the hosting environments, the level of skill and knowledge within the team. And more often than not, it also depends on personal preferences on which tool people want to use. There are also some scenarios where you might need to have multiple tools depending on what the requirements are for your CI/CD pipelines. For example, you might select one tool to help with complex configurations and another tool to actually manage the infrastructure into a multi-cloud environment. What is important is the ability to easily scale infrastructure and reducing configuration drift with reproducible configurations. When considering infrastructure as code tools, you will often hear people referring to either taking an imperative or a declarative approach to writing code. The imperative approach allows you to specify the steps involved with making a change, and it does not deviate from these steps, whereas the declarative approach allows you to define the requirements, and the IaC platform then implements the necessary steps to achieve the desired outcome. So the declarative approach is focused on the final outcome rather than those individual steps taken to get to that final state. The declarative approach is often more easily understood, whereas the imperative approach can be more complicated, but it does provide that greater control over the deployment of infrastructure. Another area of focus is deciding on whether to establish mutable or immutable infrastructure. Mutable infrastructure as code allows modification and updates after being provisioned and will provide flexibility in terms of ad hoc customizations. This might be required to respond quickly to potential security issues, but this obviously also can impact the infrastructure versioning. Most infrastructure as code instances will be implemented as an immutable infrastructure design. which will mean that the infrastructure isn't susceptible to any configuration drift after the initial deployment. When the infrastructure requires modification, the code is updated and deployed, while also being documented and versioned to reflect the latest iteration of the configuration design. Moving to an infrastructure as code environment might require additional investment into newer security and monitoring tools and services that are focused on a DevOps way of working. So adopting infrastructure as code enables a consistent approach to infrastructure provisioning, which will ultimately result in an accelerated software delivery lifecycle. However, it doesn't always increase the speed to deliver new features and services quickly. When you make changes to the infrastructure, you need to change the code as well, and that will need to be QA'd and then released through multiple environments. Overall, I think the benefits of infrastructure as code outweigh the disadvantages, but it is important to consider the skill set required to manage such environments and ensure that errors are not replicated across an entire environment. Development languages used to support IaC tools are in high demand, and as you'd expect, you'll pay a premium for people skilled in this area. There is also a global shortage of these skilled individuals as well. I hope that's been helpful and given you a little bit of an insight to infrastructure as code. Please let me know what other technology topics you'd like to see covered in future episodes of the podcast, and remember to subscribe and stay tuned for more inspiring tech leaders.